Okay, welcome back, everybody. So let's get started. Today we are working on the absolute value inequalities. If you remember, in the previous class, we worked on absolute value equations. Today we are looking at absolute value inequalities. So before we get into the examples on absolute value inequalities, we are going to learn the fundamental idea so that we can use that concept while solving the inequalities. So for an algebraic expression x, so when I write uppercase x here, I'm referring that as an algebraic expression, and some number k greater than 0, an absolute value inequality is an inequality of the following form. Here I have two of them. So the first one is when absolute value of x is less than 3. Say, for example, let's take some simple example to understand that. Suppose we have a number line here. Okay, when we say number line, we are talking about the values from negative infinity up to positive infinity. Somewhere in the middle, you have the 0. Now, let's think of two numbers on this number line, maybe like -3 and +3. -3 and +3. Now, what you will see is if you think of the absolute value of -3, okay, if you think of absolute value of -3, that is a 3. So if you try to find the absolute value of -3, that will be 3. Similarly, absolute value of 3 will also be 3. Now, here we are looking for the absolute value less than k. Now, if you look for all numbers between -3 and +3, say, for example, here is a 2. Absolute value of 2 is a 2, which is less than 3. When you go here, there is 1. Absolute value of 1 is 1, which is also less than 3. Similarly, on this side, if you take 1, -1, the absolute value of -1 is also 1. So that is also less than 3. And here, if you take a -2, then absolute value of -2 is also less than 3. So you can see all values between -3 and +3, all values over here. If you check here, the absolute value of all these values, if I consider these values as x, okay, if I consider these values as x, then the absolute value of x is less than 3. Absolute value of x is less than 3. So if the absolute value is less than 3, you can clearly see that the numbers are between -3 and +3. Okay, so for all numbers between -3 and +3, the absolute value will be less than 3. Similarly, that's why I've written this statement here. If the absolute value of x is less than k, meaning of that is the value k, or I should say the value x, is between -k and +k. So that is like the key or the formula. So whenever you see less than, okay, if you see less than, then meaning of that is this value inside the parenthesis must be between -k and +k. -k and +k. That is the first inequality or first rule about the absolute value inequality that you need to remember. So make sure you write that. Now, if you look at the same number line here, okay, if you look at the same number line there, for all values, you can see for all values greater than 3, like 4, 5, 6, 7, 8, and so on, the absolute value will be more than 3. Okay, and similarly on this side, if the values are like -4, -5, -6, and so on, the absolute value will be greater than 3. So on this side, let me use different color. So for all values here, where I am showing by red, the absolute value will be greater than 3. Okay, because if we have a -4, the absolute value of -4 is a 4, which is greater than 3. If you take -5, absolute value of -5 is a 5, that is greater than 3. So for all these numbers here, the absolute value will be greater than 3. Similarly, on this side, on the right, for all values over here, which are greater than 3, like 4, 5, 6, 7, 8, and so on, the absolute value will be greater than 3. So if the absolute value is greater than 3, it is for the values more than 3 or values less than 3. So if we say greater than, if we see greater than, like here in the second statement, if x is greater than, then that is equivalent to this expression here. We get two expressions. Like the first one here, we get x is greater than, this is -3, by the way. This is a -3 here. So the absolute value is greater than 3. Okay, this is -3. Here it is +3, so absolute value is greater than 3. That's why what I've written here is, this is true when x is less than -k. This is -3, so values over here are less than that. And on the other side, you can see x greater than k, the values are greater than 3. So please write these two statements. They are very, very important statements for you. And also note here, see, I have strictly used less than or greater than, but if in place of less than, if there is less than or equal to, as I have shown here, or in place of greater than, if there is greater than or equal to, even in those two cases, these two formulas are true. Okay, same formula will be true when we have strictly less than or strictly greater than, or we can say less than or equal to and greater than or equal to. So that is the basic idea. So always remember, if the absolute value is less than, then we write in this format. Okay, -k is less than or equal to x is less than or equal to k. If it is greater than, then we have two statements. You can see x is less than -k or x is greater than +k. Okay, if you have written that, now we are going to move on to example. But before we move on, if you have any question, you can ask me now. You can also send the question through chat if you want. Okay, let's go to the example now. So here I have the example. Please copy the question. We are just going to solve the first one now, part A. So you can just copy that. Solve the following absolute value inequalities. First thing we have to do is we have to solve the inequality. Solve the following absolute value inequalities. Give your solution using, so after you solve, you'll get your answer or solution. You have to give your answer using number line. Using number line, that's one way of writing the answer. The second way, using the set builder form. Next way to represent the answer is using the set builder form. And the third one we have is using the interval notation. So what we are doing here is we are going to solve the inequality first. And by solving the inequality, you will get our solution or the answer. And we have to write our answer in these three different forms. There are three ways to represent the answer. That's why we are going to use all three ways here. So let's begin with the first one, A. So here in A, we have 2 times the absolute value of 2x minus 5 is less than or equal to 14. So we have less than there. Okay, this inequalities contain less than. What we know from the previous slide is if the absolute value of x, let me write the complete statement. If the absolute value of x is less than some value k, okay, some value k, then this x is between -k and +k. Then -k is less than x is less than k. So that is our formula, or that is the definition of less than. Okay, absolute value of x is less than k. So we'll be using that over here. So for that, as you can see here, we just need the absolute value on the left hand side. But in our equation, what we have is, here is the absolute value of 2x minus 5, but from outside it is multiplied by 2. So what you have to do is, we have to remove this 2 by dividing on both sides by 2. If we divide on both sides by 2, that will be removed. So this is what I'm doing. I have 2 times 2x minus 5 is less than or equal to 14. I am dividing on both sides by 2. So I'm dividing here by 2. I'm dividing here by 2. If you divide by a positive number, inequality sign will remain the same. So you don't have to worry about that. Now you can see 2 and 2 cancels. You'll get absolute value of 2x minus 5 is less than or equal to 14 divided by 2 is a 7. Now you can see we have a less than. Absolute value is less than negative 7. So when you have less than some value, then the quantity inside the absolute value will be between negative of that number and positive of that number. So if we write that, this will be negative 7, because our key number is 7. So negative 7 is less than or equal to 2x minus 5 is less than or equal to positive 7. So here you can see here is a k. We write negative k on one side. We write positive k on one side. And whatever is there inside the absolute value, we write that in the middle. So we did the same thing. Here we have a 7. So here we write negative 7. On the other side, we write positive 7. And whatever is here inside the absolute value, we write it in the middle. Okay, we use the definition. Now what you have to do is we have to find the inequality for x. So now, if you look at this inequality carefully, here is a negative 5. So what we are going to do is to remove this negative 5 from the inequality, okay, in the middle, from the expression in the middle. We add 5 on all these 3 because there are 3 parts there. So we add 5. We add 5 here. We add 5 here. And also we add 5 there. Like that. And if you add 5, you can see on the left, it is 5 minus 7, which is a negative 2. Negative 2 is less than or equal to, here in the middle, negative 5 and positive 5, they cancels, or the sum will be 0. So we just have 2x in the middle. And then less than or equal to 7 plus 5 is a 12. Now we are almost done because solving the inequality means we just need x in the middle. We have a 2x there. So in order to remove that 2, what we'll do is we'll divide each of them by 2 again. To remove this 2 in the middle and just to get that x, we divide throughout by 2. So we get the final result now. So the final result will be, you can see negative 2 divided by 2 is 1. 1 is less than or equal to 2 and 2 cancels, that is x, or 2x divided by 2 is x. Less than or equal to 12 divided by 2 is a 6. So that is the solution. Okay, that is the solution to the absolute value which is given here. Meaning of that is for all values between 1 and 6, okay, all values of x between 1 and 6 will satisfy this equation. Whatever you plug in between 1 and 6, it will satisfy this equation. That is the meaning of that. Now, what we have to do is we are just done solving it. See, there are a lot of things to do in this problem. We are asked to solve, so we have solved it. After that, we have to present the solution. So you can see what we are doing throughout. Pretty much in this last step, when you get 2x here, okay, there is 2 times x. We need to get the value of x, so we divide by 2. So when you divide by 2, we just get x. Our goal is to find x in the middle. That's why here we divided by 2. So once you divide by 2 in the middle, you have to divide each of them by 2. So we get x in the middle. Always remember that. So when you have x in the middle, then that is your solution, because solving the inequality is to get the value of x. Now here you can clearly see x is between 1 and 6. So what is the meaning of that? If we draw a number line to represent this value, let's try that. Okay, let's draw the number line. So number line goes from negative infinity to infinity. So you can mark that from negative infinity up to infinity. You'll have 0 in the middle. Now, in this case, what I have is I have two numbers, 1 and 6. So I need to mark those two numbers on the number line. 1 is somewhere here. 6 is somewhere there. X is between 1 and 6. Look here, X is between 1 and 6. That means X lies between these two values. Here is your X, that is the meaning. X are all these values from 1 up to 6. X are all values between 1 and 6 because X is between 1 and 6. And also, look at this screen carefully. Here we have equal to sign. Here also we have equal to sign. Meaning of this equal to sign is this 1 is included and also this 6 is included. So if the numbers are included, what we do is we put a dot there to represent that these two numbers are also included. Okay, to represent that these two numbers are also included, we put a dot like that. So that is the solution in the form of number line. We are asked to show the solution in number line. So this is how we can show our answer in number line. So this one, the first one we have done here is solution in number line. So we are showing the answer using number line. Second, we have to show the answer using set builder form. Set builder form. Set builder form is another way of writing the answer. And what we do is, say, in the set builder form, everybody look at the screen now. To write it in the set builder form always have this curly braces or called curly brackets. Okay, so we begin this curly bracket, and then what we do is, this is how we can write the set. That's why we write this bracket. And what we say after this is, the solution is the set of all x. This is what we write, x, such that this line, vertical line means such that, okay, our solution is the set, this curly bracket that I begin here is the set of all x, because these are the x values, such that x is between these two. So whatever answer we get here, we need to write here. So we got 1 is less than or equal to x is less than or equal to 6. And we close that bracket. So in set builder form, this is just a standard mathematical way of writing. Okay, nothing fancy there. Just a standard mathematical way of writing the solution using set builder form. All you have to do is you have to begin the curly bracket, then you have to write x, and then this vertical line, meaning such that set of all x, such that whatever answer you get here, you'll write that and close the parenthesis. Okay, that is the other way of writing the solution to the absolute value inequality, which is called the set builder form. And the last one is we have to write in interval notation. So let's write the interval form or interval notation. Interval form. So in interval form, what we do is we write this interval. See, we look at the number line and we write the interval. Our x values are from 1 up to 6. So it is from 1 up to 6. That is the interval. And we check whether 1 is included or not. See, we have a dot there. If there is a dot, meaning of that is x is included. If it is included, we put a bracket. We put a bracket. If it was not included, we put a parenthesis. okay? Because this is included, we put a bracket. Now on the other side, if you look at 6, 6 is also included because there is an equal to sign here. That means it is included. So if it is included, we put bracket again. One more time. If it was not included, then we write parenthesis. Parenthesis for not included, bracket for included. Okay. So this is our first example on how we can solve the absolute value inequality. If you have a question, you can ask me now. You can also send the question through chat if you want. Okay, we'll move on to second example here. Example 2. Okay, let's solve B. So in B, we have absolute value of 2x minus 6 is greater than 4. Absolute value of 2x minus 6 is greater than 4. Now you can see here we have a greater than. Okay, here we have a greater than. Now, if you recall the definition, if absolute value of x is greater than some value k, then we have two statements, if you remember. Then x is greater than k or x is less than negative k. So we'll have two statements from the definition in the first slide. Okay, so we are going to use this definition and solve this inequality. We already have the absolute value on the left hand side. You can see we already have the absolute value. There is nothing in front. So we can directly write two statements: x greater than k, that is this quantity 2x minus 6 greater than 4, or the second quantity will be this quantity 2x minus 6 is less than negative 4. So this implies two things. The first one is 2x minus 6 is greater than 4, or 2x minus 6 is less than negative 4. Those are the two things. So now we have two inequalities, two linear inequalities. We are going to solve each of them. Now to solve the first one, you can see 2x minus 6 is greater than 4. So you can add 6 on both sides. So if you add 6 on both sides, you will get 4 plus 6 equal to 10. And on the left hand side, 6 minus 6 will be 0. So 2x is greater than 10. Now, if you want to find the value of x, there is a 2 times x. So divide on both sides by 2. So you get x is greater than 5. So from the first, you got x is greater than 5. Now, if you look at the second, again, you'll add 6 on both sides. If you add 6 here, that will cancel. On the other side, if you add 6, it will be 6 minus 4, which will be 2. And finally, we get 2x equal to 2. That means to find the value of x, we have to divide on both sides by 2 again. So 2x divided by 2 is a x is less than 2 divided by 2 is 1. So what I got here is, the first thing I got is x is greater than 5. Okay, this one is x is greater than 5. I have or in the middle, as you can see, or x is less than 1. This is my solution. When I solve it, what I obtain here is x is greater than 5 or x is less than 1. We solved the inequality. We got this value. The value of x that satisfies this equation will be x more than 5. When I say x more than 5, the numbers like 6, 7, 8, 9, 10, and so on. And here x less than 1, meaning 0, negative 1, negative 2, and so on. So if you want to represent this in number line, let's see what we get. Number line. to show the solution in number line, first we'll draw the number line. First, we'll draw the number line. Then in the middle of the number line, we'll have 0. You can show that, or you can directly write these values. You can also do that. The two important values are 1 and 5. So you can just mark those values, 1 and 5, like that. You don't always have to show that 0. You can just write like that. But one thing here, look here, with this 5, when you have x greater than 5, or here with this x less than 1, there is no equal to sign. Meaning of that is this 1 and this 5 are not included. If they were included, if you remember, we used to put a dot there, right? But these values are not included. If the values are not included, we put a circle like this, because these values are not included. So we put a circle there. Okay, we put a circle there because these values are not included. And the true values of x are, as you can see, one possibility is x is greater than 5. So here is 5. When I say greater than 5, it is on the right like this. All these values, okay, all these values over here are greater than 5. So these values are included. So I'm showing by arrow on that side. So all values more than 5 are the solution to this absolute value inequality. Similarly, x less than 1, here is 1. So less than 1 means to the left. So all values to the left of 1, they are also the solution. So you can see that everything on this number line are solution except the values between 1 and 5. The values between 1 and 5 are not solution, but the values less than 1 and more than 5 are the solution. So this is how you can show your solution using a number line. Okay, that is the representation of the solution on a number line. Next, we are going to write the solution using set builder notation. So let's do that. Set builder form. In set builder form, we write it as a set of all x such that, okay, curly bracket for set of all x, because we are talking about the x values, such that here is the condition: x should be greater than 5 or x should be less than 1. So whatever is here, we'll put it here. So we have x greater than 5 or x less than 1. That is the solution using set builder form. So we are asked to write the solution in 3 different forms. The first one is number line, which is this one. Second is the set builder form, which is this. And the last one is using the interval notation. So let's go for that. Interval form. So in interval form, we write the interval using this number line here. Wherever the x is true, that is the interval. So the first interval, you can see we have the x values from -infinity up to 1. We have the x values from -infinity up to 1. And here you can see at infinity, okay, at -infinity or positive infinity, we always use parenthesis. At infinity, we always use parenthesis. And here at 1, everybody look at the screen now. At 1, this 1 is not included. You can see there is a hole there, right? There is a circle there to mark that this 1 is not included. If it is not included, we put a parenthesis. If it was included, we put a bracket. Similarly, our answer is not here in the middle, but our answer is here again, from 5 up to infinity. There is a second interval, from 5 up to infinity. So you'll write that, from 5 up to infinity. And as I said, at infinity, we always put parenthesis. At 5, this 5 is not included. There is a hole. So we'll put a parenthesis again. And because we have two intervals, our x value can be on this first interval or x value can be on the second interval. When x is on these two intervals and we want to combine these two intervals, the way we can combine or unite this interval is by putting our uppercase U in the middle. Okay, if we put uppercase U, the union sign in the middle, meaning of that is I'm combining these two intervals. That is, our x lies in this first interval or in the second interval. Union means this or here. So this is how we can solve the absolute value inequality and present the solution. So we did three things here. We solved the absolute value inequality. That is the first thing here. Okay, in fact, we did four things. That's the first thing. Second thing, we saw the solution on a number line. Solution on a number line. Next, we saw the solution using set builder form, which is here. Okay, that is the set builder form. And finally, we showed the answer in the form of interval notation. Okay, using the interval notation. So we did four things. We learned how to solve. And remember, while solving, you must use the definition that we have studied on the first slide. Okay, you have to use the definition and solve it. Once you solve it, you have to write the solution using three different forms: on a number line, using set builder form, and using the interval form. Okay. If you have question on this part B, you can ask me now. You can also send question through chat if you want. Okay, now let's go to next example. So now we are going to solve part C here. Same question, solve the inequality and give the solution in three different forms. So let's begin with the problem. So part C, we have a fraction 1/3 minus x inside the absolute value is less than 2/3. So this is the less than, right? There is a less than. So if you remember the definition, we have if absolute value of x is less than k, then we have negative k is less than x is less than k. So we have to use the proper definition. Because there is a less than, we are going to use that definition. So always remember to use the correct definition while solving the absolute value inequality. So if we use that definition and rewrite this, then you can clearly see we have x between negative k and positive k. Similarly, this 1/3 minus x should be between negative 2/3 and positive 2/3. So we write this as negative 2/3 less than 1/3 minus x is less than 2/3. So we write this value 1/3 minus x in the middle. On one side, we write negative 2/3. On the other side, we write positive 2/3. Because when we have a k here, on the left, we have a negative k. On the other side, we have a positive k. We just use the definition. Now, in order to solve the inequality like this, see here in the middle, you have to be very careful. Here in the middle, we just need x. There is 1/3 minus x. So first, we need to remove this 1/3. That is a positive 1/3. So we have to subtract 1/3 everywhere. So let's subtract 1/3. Minus 1/3 here. Minus 1/3 in the middle. Minus 1/3 there. So if you subtract here, see here we have a negative 2/3 and here we have a negative 1/3. Negative 2/3 and negative 1/3 is negative 3/3, that is negative 3/3 or negative 1. Negative 3/3 or negative 1. Now we have a less than, and then see 1/3 and -1/3 cancel. What is remaining is a negative x. See, there is a negative x, minus in front, so negative x. Negative x is less than 2/3 minus 1/3. 2/3 minus 1/3 is 1/3. Right? 2/3 minus 1/3. 2 apples minus 1 apple is 1 apple. So just like that, 2/3 minus 1/3 is a 1/3. We are almost there, but if you look at the middle, we have a negative x. We cannot have negative x there. We must have a positive x. So if you want to get a positive there, we have to divide throughout by -1. So if you divide that by -1, you can see negative over negative will be positive. X divided by 1 will be x. So to make this positive, we have to divide by -1. So if we divide by -1 in the middle, we have to do the same thing here. We divide by -1, and here also we divide by -1. Now here is the magic. See, x -1 divided by -1, that is a positive 1. Okay, and here negative x divided by -1, negative over negative will be positive, x over 1 is a x. And then 1/3 divided by negative. If you divide by -1, it will be -1/3. Because if you divide a number by negative, it will be negative. And when you divide by 1, it will be the same value. That's why -1/3. But look at the screen. We are dividing throughout by negative. If you divide by negative, the inequality sign will flip. Okay, inequality sign will flip. Here is a less than, so this will be greater than. And also here is a less than, so this will be greater than. So that is my final result. So my final result is your x is between -1/3 and +1. So this is my final answer. Now all we need to do is, this is the solving. We need to present the solution using a number line, set builder form, and interval form. So that is our work now. First thing we are going to do is we are going to present the solution on a number line. We are going to present the solution on a number line. So first, draw the number line, horizontal line for a number line. At the end of the number line, you'll put -infinity and +infinity. There are two key numbers here, -1/3 and 1. We write the lower number on the left. So first we write -1/3. And the other one is 1. We put the numbers like that. And then we check here. See, there is no equal to sign. There is no equal to sign with this 1, or there is no equal to sign with this -1/3. That means 1/3 and 1 are not included. So we just put a hole there, just like that. Okay. And here you can clearly see your x is between these two values. When we say between those two values, your x is here. This is where you have the x. X lies between -1/3 and +1. Because if you just try to read this one, you can see x is less than 1. And if you try to read the second one, you can see x is greater than -1/3. So greater than -1/3, less than 1 are the values between -1/3 and +1. So we are showing the solution over there. That's your number line. Now let's write using the set builder form. Set builder form. So in set builder form, we write the set notation because the solution is the set of all x such that, we just put this set of all x such that, here we have the result, x is I mean, 1 is greater than x is greater than negative 1/3. And we close it. That is in set builder form. And finally, we can write the answer in the third form. I think now the third form is easy for you, interval form. Let's write this down. In interval form, you can see the values are from negative 1/3 up to positive 1. From negative 1/3 up to positive 1. And you can see negative 1/3 is not included. There is a hole there. So we put a parenthesis. Similarly, this 1 is not included. There is a hole there. So we put a parenthesis like that. So that is the answer in the form of an interval. So always remember, whenever you're working on solving the absolute value inequality, you have to use the proper definition. For example, here we use the definition for greater than. So we solve accordingly. In case of greater than, we get or, and we get two inequalities like this. And if it is less than, then we'll have one inequality, a compound inequality, and the values are between two given values on the number line. Okay, so that is all for the absolute value inequalities. But remember one thing, last time we worked on absolute value equation. Before that, we work on radical equation. And then here we work on the absolute value inequality. So that's all we have for the second unit. In first unit, if you remember, in first unit, we work on equations. We work on linear equation. We work on quadratic equation. We work on applications. That was a long unit, but this unit is a little bit short. In this unit, we just work on radical equation. The week before, right? Previous week, we work on absolute value equations. And then this week, we work on the absolute value inequalities. Okay. So what you have to do is, if you have not completed the problem up to number 10, that was for the last week. Now we have the additional questions, 2 or 3 questions. So if you solve the additional 2 or 3 questions, you'll be able to complete everything from second exercise. So what I want you to do is complete all the questions from the second exercise as a homework. So next week, we are going to begin third unit. Okay. Third unit will be a little bit different. It will not be equations.